Good morning, everyone. I hope everyone is doing okay and ready for another day of learning. My name is Ashish, and I would be helping you today to learn a little bit more on AWS side. And I am joined with wonderful colleagues from AWS. I'll ask them quickly to be on camera so that we can get introduced and we will get started. I am adding them one by one. So we today have Prasad, Chris, Jamila, and Alex. Hopefully everyone can see us. And we are really, really happy that you are still continuing with us. It's been Saturdays, it's the third Saturday, and obviously getting time on Saturday is little complicated. We have commitments, personal stuff, something which is pending, and still you are here helping us to make you learn something. That's much, much appreciated. Thanks, everyone. And we would be hoping that you would have a great time. We are monitoring the chat, so please ask questions. We would be answering as much as we can, but in case we are not able to answer question, reach out to us on LinkedIn and we would be happy to answer any questions you have. And if you ask questions before, somehow we forgot it, so we apologize for that, and you can just ping us again and we will take it from there and answer the questions which you have. Alex today looks different. Alex, where are your glasses?
Yeah, that thing. I was a little bit in a rush to get to the chat, so I
Yeah,
didn't get
come
my
on.
fabulous glasses and fabulous
Yeah.
camera. So that's what you got,
Exactly.
guys.
No worries. Thank you. So we will get started quickly. And if there are questions, feel free to ask them. And we will obviously talk about lots of stuff, technical, non-technical, and behavioral. So please feel free to ask question. And let me switch from the camera view to the screen view so that you can focus more on the content and we can then get started. Thanks, everyone. And let's get started now. So So what we are going to discuss right now, we are going to talk about week 3, and in this week, I want to discuss about concepts related to Amazon EC2. So let me quickly show you that what I plan to discuss today. So I plan to discuss Amazon EC2. Then obviously service is just not a technical thing. We need to understand the logics behind and how customers use those service. So we'll talk about Amazon EC2 use case. Crystal will help us there, and then we would be talking about how to transition from non-tech domain to cloud. That is a common question we get on our LinkedIn, that hey, I'm working into a field which is non-technical, but I have aspiration to become a cloud person. So how I transition from that? So Prasad and Jamila will go through that. Jamila has done that journey, and Prasad helped her in getting that journey done. So we will hear from them firsthand that how it looks to transition from non-tech to domain. And we would extend this discussion in the next module, next Saturday, where we'll talk about people from technical domain, that how you can expert who can have expertise as expertise as a technical person, but maybe from non-cloud to cloud domain. So we'll discuss all the stuff as we move forward. Let's get started with how our day looks like. Second session, will I be able to manage this session? Yes, Mustafa, should not be a problem. So this session builds on existing knowledge, but if you didn't see the second, that's fine. You can later watch it, but we will try to keep it as isolated so that you do not interfere, you do not get problem with the other stuff. Now, one thing which we already discussed and probably you should look for is that what are the global infrastructure component. We discussed that. We also discussed about components related to storage. So that's what we discussed last time. And we will be now working towards platform services. But before that, we have to focus on the compute part. So today is all about how I ensure that I can provide the compute services or the processing power for my application. That is very important stuff. So we'll talk through compute option. Let's see what this compute is. Now, the compute has different aspects in AWS. What I'm focusing today on is on compute done by Amazon Elastic Compute Cloud. That is what we call EC2 in a short form. So we'll discuss what EC2 is, how it works, why we need it. So let me take a little bit of back step and talk about how computes was done initially. What was the traditional approach we had? So in traditional approach of servers, what we used to do, we would have a physical server. You name the vendor, Dell, IBM, HP, it could be anyone, and those vendors would give you the compute power. Once you have this physical hardware applied into your data center or racked and stacked, what you would do, you would need some operating system running on top of it. It would be Windows, it could be Linux, it could be Solaris, depending on what type of applications you want to run. And once this is done, then you would start deploying your application, which could be .NET, could be Java, Python. It purely depends on how your application is configured. And once this is ready, you are able to host your application. The problem with this approach was it was good for a very long time, but then we started realizing that our servers are becoming powerful and powerful. They have lots of CPU now, lots of RAM available. Now, if I consider what a server used to look like 5 years before, probably a laptop would have more processing power than that server now. So every time we have lot of component being added into the server, performance is increasing. And if we look at that, how much I am actually using that server, probably it was just 5 to 10% of utilization, which is basically waste of the resource that I don't want everyone to waste 5 or 10% and just keep on working on paying money and paying some lot of stuff. So this is not a good thing. We don't want that. So then came the idea of virtualization. What we did in virtualization approach, we took the same physical server, and on top of it, we started installing hypervisors. These are coming from different companies like VMware, Hyper-V, Oracle Virtual Machine. These are the software component which act as an operating system, but is a very fine-tuned operating system. And on top of that operating system, we would start creating virtual machine. So that is what a virtual machine is, which is a component running on a hypervisor and leveraging the physical hardware, but not directly through an hypervisor. It is leveraging it. And once I have a virtual machine created, on top of it, I can install our operating system. And once our operating system is ready, obviously I can have application running. So this was a compartmentalized approach where we did what we have used the same physical hardware, but by leveraging hypervisors on top of it, we are able to run multiple virtual machine, and each of the virtual machine could be running a different operating system, a different application. So Hyper-V from Microsoft, yes, exactly. Hyper-V is a Microsoft hypervisor. VMware calls their hypervisor ESXi or vSphere, and Oracle has different naming for that. So once we started using this approach, advantage was that we were able to have a higher utilization for our server. Think like that instead of having an individual house where only one family is living, what we started doing, we started putting a building, and in that building there can be multiple families living, and they could be sharing some stuff like maybe the lift, the staircases, maybe the swimming pool or garden, but still they have their own compartments or own way of living and having privacy. So that is a way where virtualization came in. So think of virtualization as a way to utilize the same piece of land, but with more tenant inside, so that you could have a better approach towards utilizing your services. So that's how your virtualization came into picture. So we use virtualization. When I talk now specifically about Amazon, let's see how our approach is. So in traditional way, if you want to deploy a virtual machine, you would need a hypervisor coming from these vendors. Hardware, probably hardware agnostic. You could have a Dell, IBM, HP hardware. It doesn't matter. What we do now, we have come up with our approach called AWS approach. Now, the service we are discussing here, EC2, is called virtual server into the cloud. So it is still a virtual server, but it is operating into cloud. And this service, I would say, at least is 15 years old. So in 15 years, we have, as a company, AWS identified that we were able to identify that, hey, what kind of best combination works for us in terms of hardware, what software should be there, what kind of configuration should be there. So we started looking for the best and optimized way to run this virtual machine, and that manifested into a solution which we now call a Nitro system. So instead of keeping and getting vendor specific hardware, vendor specific software, what we did, we were able to create a system which we call Nitro, and which is combination of hardware and software. It's a purpose built hardware and software combination fine-tuned purely to run Amazon EC2 machines on top of it, and we have removed unnecessary component and added the component which could optimize the performance of our application and our virtual machine. So that's how we have created this Nitro system. And once this Nitro system is ready and functional, customer don't directly see Nitro system. What a customer interacts with the instance. So instance is in a way what we call virtual machines. So instance is a virtual machine. That instance would have an operating system, and then there would be applications running on that. Vijay has a question like which hypervisor we use. Initially, if I remember correctly, it was Zen. It was a very customized version of Zen. I don't think we use it anymore. This Nitro system, as I said, Vijay, it is a hardware and software combination. So we have customized our specific hardware and specific operating system, because maybe that Zen or KVM has something which we do not need. So we removed that component and we highly customize. So that's what Nitro system is all about. Okay. So we use Nitro system to run our application. So how much percentage of EC2 is Nitro? I don't think we publish that information, but I would say that any new machines you launch, any new instance type, they are probably coming from Nitro. But percentage wise, I don't think that would be a number available somewhere, because in different region, in different availability zone, that component may be there. Is EC2 similar to Kubernetes? Answer is no. Kubernetes is a orchestration service for container. It is not a hypervisor. Kubernetes maintains the container once they start. So EC2 is exactly is a VM. It is exactly a VM. Thanks, Alex. Yes, Kamesh, it is a EC2. Will we also have a session about Docker and Kubernetes? It depends. We will see that how much basic components we can cover. And if we have time, I would be happy to walk you through the Kubernetes component. All right. So on this hypervisor Nitro system, we may have multiple instances running. So two things you have to be clear here. Service is called Amazon EC2, and on the service we have a component running which is called instance. So service is what AWS would manage for you. We would take care of this service for you, and you as a customer, you start by creating, hey, I am looking to create a instance, I am looking to create a operating system of Windows. So you focus on creating instance. So let's go ahead in the console and let's see how we would be deploying a small EC2 machine, and we'll get started with that. So let me quickly walk you through that process. Okay. Now, what I plan to do here, I plan to deploy a small web server. Let me write down so that everyone is aware that what we are going to do here. So my requirement is that I want to deploy a web server on Linux and host a small web page. That's all I need to. So for that, what I would be needing, I would be needing a physical server. Here it is no physical, it is all virtual, so it is will be EC2. Then we would be needing an operating system. Then we would need some component which will make it a web server, and then we will host a web page on that. So that's what I am going to walk you through how it would look like. Now, everything is done through AWS Management Console here in this demo, but you can do everything here in a command line also, or maybe through automation, or maybe through script. EC2 is a regional service. So I have to first select which region I want to deploy it into. These are the regions which are available in AWS. If you do not remember them, please watch our first video. So these are the regions where the applications can run. I have selected Ireland as a region, and now I can look for the service called EC2. This is my service EC2, and I would now start adding a virtual server with Linux operating system, and would install a web page on that. That's what we are looking forward to. Okay. Okay, let's move forward here. So first thing I get here is the EC2 dashboard. Dashboard gives me like what are my current view, if I have multiple instances running, if I have some IP addresses assigned, if I have some volumes created, that information would be displayed to me here. Right now, I am interested in a component here, which is called launch instance. And this launch instance would walk me through the wizard of launching a EC2 instance, right? Now, EC2 instance is not an isolated component. It works with a network configuration, because obviously to server you would need an IP address, you would need a communication channel. So that would be required, and that we will be seeing in a minute. So let me start with launch instance. I have launch instance, which is a very simple way to get started. Now we give you a free tier. So in case somebody wants to experiment, and if you are within that free tier like T2 micro machine, you won't be getting charged for 750 hours per month. So it's a good way to get started on that. So first thing, it's a wizard based process. I have to give it a name. Name would be identifier. So let's call it BeSA web server. That would be my name. Then I may want to put some additional tags associated with that. Tags can help me in identifying that particular server. So we will see that in some time, that how tags can be assigned. So this is my BeSA web server, which I am going to deploy. Okay. Now, next thing I have to select here is what my operating system would look like. In traditional environment, what you have to do, you first create a virtual machine and then you use some images to install a operating system, which obviously takes time. You select Windows and then you go through Wizard. It takes 10-20 minutes to get installed. You have to click on next or automate it. We don't want customer to waste time on that. So what we give you here, we give you some pre-configured templates. On those templates are called AMI, Amazon Machine Image. So what this AMI is, it is commonly used operating system images which we feel customer would be using again and again. So to save customers time, we combine them into a template, and those template is like a drag and drop kind of a component. You can select what kind of operating system you are looking for. So these are the common ones, quick start, which we see customer using. Now when I say, let's say, hey, I'm looking for a Windows machine, so I can select Windows, and here in that it would be telling me, okay, do you only need plain vanilla Windows, or are you looking to get any additional software with that? So see this, Windows Server 2019 base, and I have other option that I need a Windows server with containers. I need another Windows server with SQL standard 2017, or I'm looking for 2019 enterprise, or I'm looking for Windows 2022. So it's purely up to you. So it is a good way to look for what you are looking, what is your requirement, and select from there. My requirement is to keep Linux, and Amazon has also come up with our own flavor of Linux, which we call Amazon Linux. So this Amazon Linux is a fine-tuned version which has some component already installed to facilitate your journey into cloud. Like it has some agents installed, it has some monitoring tools installed. So that's what is called Amazon Linux. So we are selecting Amazon Linux here. So first thing I selected is a what operating system my requirements are. Now, am I limited only to these operating system? Answer is no. What customers can do when they are operating at large scale, they may create their own AMIs, which is a custom version of AMI. So if I know that in a particular web server, I always need a specific component to be installed, or I always need a service to be stopped and not started at all. So that time I can take a plain AMI, then customize it as per my requirement and save it. That would become my AMI. This is owned by me, and I have some AMIs here in Ireland region, like I use for stress testing. I use this for monolith Node.js, another SQL server, a master template for something. So these are custom AMIs which you can create on your own. So that is my AMI, and these are the quick start. If you feel no, these are not solving my problem, I need a very specific type of software to run, that time we have lot of partners who give you AMIs to start with. These are called my marketplace AMI. So marketplace AMI, AMI is a ISO image in a way, but it is not a traditional ISO. It is a template, I would call it, not a ISO, because ISO you boot from, and then you have to install operating system on that, right? But here it is a template which is ready to use kind of a stuff. So it's not ISO, it's not bootable directly, but it is usable directly. So see this. So this is what my quick start AMIs are. 45 commonly used. My AMI, which I have created, and see this AWS Marketplace AMI. These marketplace AMIs are coming from different vendors. So, hey, I am looking to install a VPN software, or I am looking to deploy a machine learning based model, or I am looking to deploy a business application. So select that category and you would be able to see that vendors have created their AMIs, and they are made available. So you can take that vendor's AMI and you do not have to waste time in installing and configuring that. So I'm looking for WordPress. Go ahead, deploy that. Now I'm looking for 3CX phone system. I'm looking for CSI Red Hat Enterprise Linux, and maybe I'm looking for Odoo package by Bitnami. So these all marketplace AMIs are available, which I can directly leverage. So it is purely up to you how you want to get started. If you are experimenting, probably you will start with quick start and select Amazon Linux here. Now, two things here. I can select a architecture which is called x86. Now, what is x86? x86 is the software component which is fine-tuned for x86 architecture of computers, which is, if I put it in a very specific thing, I would say this is something which is x86 based off software is for Intel based processors, and it is for AMD based processors. So that's what a 64-bit x86 architecture is. Amazon has come up with our own processor, which is called Graviton, which is based on ARM chip. So if you feel that my workload would not require a specific instruction set from Intel and AMD, and I want to keep cost lower, you may select a 64-bit x86 also. So should not be a problem. So these are the available options which I can choose. So first thing I have to select is what is the operating system I'm looking for. Once I've made that selection, next thing I would be selecting would be based on instance type. Like I would say what type of performance I'm expecting. Am I looking for 2 CPU or 10 CPU or 100 CPU? That information I have to pass on. That is called instance type. So I'll walk you through what instance type is. So first selection I made, I would be using Amazon Linux 64-bit. Let me get started by selecting it. What is the next option? Let's go ahead and see that. Give it a minute. It is coming up a little slower today. Yeah, see this. So I selected a AMI. What's next? Give me a minute, please. Now, here is my option for instance type. Instance type is basically your way of saying how much CPU, memory, and other configuration I want to associate. So you can select what kind of performance you are expecting. These are different instance type T1, T2. Then you may search for other instances, like if I'm looking for a C5 or C4. What this C5, C4 is, I'll explain that in a minute. But these are the performance characteristics of that particular instance, that how much performance I may expect from that instance. So it is in terms of CPU, memory, some additional settings associated with that. So we can select it. Now, if you see here, we can clearly show you there are some free tier eligible instances. So you can select these, and then you won't be paying money if you are within 750 hours of actual limitation. So that should not be a problem. So I'm selecting T2 Micro, which will give me one CPU and 1 GB of memory to work with. I may want to log into this machine afterward. So that time I can select a key pair, but it is also possible that I may not want to log into this machine. Maybe I do everything through automation. So I can even create a machine without having any login information. We have other ways to connect to it. So key pairs can be skipped if I need to. Next component comes networking. So I can select what VPC it would go into. VPC stand for Virtual Private Cloud, and this is a longer discussion. So we will be discussing that into next Saturday. We'll talk about what VPC is and how VPC actually works. Plus, I have some additional settings related to security. I can control what kind of traffic would be allowed. So I can say, hey, I want to allow SSH traffic from anywhere. That doesn't make sense from security perspective. So I can say no, I can put a custom IP range. So only those people would be allowed to access my EC2 instance from SSH, or I can say, hey, detect my IP and only allow me to do SSH. No one else should be allowed to do detect IP address connection to that. So that I selected my IP here. I am making this a web server. So I would prefer that I allow HTTP traffic from internet so that everyone can access this web server. 750 per account. Yes, exactly, Kamesh, it's per account. per account. Total 750 hours of T2 micro. So we have allow HTTP traffic from internet. So we would be getting a firewall port open on my instance, which will allow port number 80 to come in from anywhere because we want to make it a public web server. Here is my additional storage option, 8 GB or any other type of disk. And if you see here, different type of volumes can be added. We will talk about volumes also in a minute. So this is my configuration of storage. I have some additional settings to configure. I can configure here something called a spot instance. I can associate an instance profile, which is basically a permission set for my instance. I can put a host name type on that. Currently, it will pick up through IP address. We may have a DNS setting configured with that, some auto recovery option, shutdown behavior, and lots of additional setting. One setting which I am particularly interested in this page is called user data. What this user data is? So if you remember, I selected that I want a Linux operating system. So that's fine. I would get a Linux operating system. Now, is this Linux operating system customized as per my need? Answer is no. We do not have that Linux machine customized as per my need. I want it to become a web server and I want to host a small website on that. So we need to customize some settings here. That is what is a user data. So we will talk about what a user data is. User data is a script. Now, if it is Linux machine, I would be passing a script which Linux operating system can understand. If it is Windows machine I am deploying, I would be putting a PowerShell script which my Windows machine can understand and can give me the required desired state of my configuration. So let me quickly show you a sample script which I am going to use to make this web server. Let me go back there. See, this is the script. What I'm going to do in this particular script, sorry, I am going to bin bash, means going to command prompt, using yum update to update all the components there. And then I am saying yum update install httpd. That is basically saying, hey, I also want my httpd service to be installed on that, and then create a page called index.html in the directory where you would display, here is my web page, and that would allow me to host my application. So that is a sample application which I'm going to deploy. It won't do fancy stuff, but it would just say, what is my web page? It will say, welcome to AWS, here is my web page, and it would be hosting it into the directory /var www.html, and the file name is index.html. Now, if you have a complicated script here, which would make your machine join Active Directory or go to GitHub and deploy application or run some antivirus software before we get started, so that is up to you how you want to put settings here. So, but it is very easy to just get started with this type of script, and there are lots of samples available. I would be sending some reference link in the reference today where you should be able to see these things into much detail, right? So hopefully everyone is following along. I would use this script, copy it and paste it here so it would be executed. By default, it would execute one time only when the machine is getting created for me. Afterward, if I reboot, it won't execute. That is default, but it can be changed. Here is my summary. How many instances I am looking for? One. What operating system? Amazon Linux, T2.micro. I am having a new security group created, 8 GB volume associated. And once I am happy with all the setting, I can go ahead and say launch instance. And what is happening now that one of the instance based on the configuration I specified is getting ready for me. Okay, so we submitted this information to AWS backend, and AWS backend is now figuring out that where is the best physical server to launch the required configuration, how many CPUs you are looking for, what kind of operating system, what network configuration you specified. Based on that, we would select a suitable physical host, suitable system, and launch your EC2 instance on that particular location based on the configuration you have specified. And you can monitor it. Launch logs. What we give you an instance ID, which is I dash a random number. And here we say what we were able to successfully do. We initialize the request, creating security group rules, and we started launch of instance. And this is where my instance is getting launched for me. Okay. Hopefully everyone is following along and understanding what is happening here. So we are able to decide. How does scheduler decide where to put the VM? Vijay, it is purely based on what you requested and what capacity is available in our environment, right? So that logic, I don't think a customer would get benefited if they know about it. We make sure that based on the configuration you have requested, we allow you to host it on the best suitable platform for it. But maybe we have thousands of servers running, which one would get selected? There is some smart logic running behind which would make sure that you get the requirement. Because as a customer, let's say you go to McDonald's, you say, I need a burger. That's all you'd say, right? You do not worry what kind of air fryer they are using, or from where their ingredients are coming in, or what is their recipe. This is a service. In a service, you request something and you get a response. How they take care? Have they hired temporary employee or are they full-time employee? Is this employee working from 10 year or 15 year? What is their selection process of employee? It doesn't matter. I am interested in getting a burger, getting a coffee, and that's the main idea of encapsulating service and not worrying about any nitty-gritty details behind it, right? Okay, so that's my server is running, and as you can see, this is my instance. This is having T2 micro. It is in running state, and I have a status check initializing. What happens here that we don't just give you instance. It may happen that while it was booting, there was some issues, there was some problem. So we always perform status checks with your machine, and that is currently initializing. So in status check, we perform two checks. First is system check. What is the system check? Let me quickly talk about what this system check is, and then what is your instance status check. Let's talk about both of the stuff. So if you remember, I told you that my EC2 instance is getting on some hardware software combination. So it may happen that this hardware software at the back end has some issue. If it happens, that we check through system status check. So system status check makes sure that the AWS system required for it are running fine. That is the first check. Second check we perform is instance status check. There is an operating system running here, right? What if operating system blue screen? What if operating system could not get connection to to networking? So that's why we will perform another check on your instances, and it is automatically done, and every time it is running. So see this, it says 2 by 2 status checks passed, and I have no problem at all in connecting to these instances. Everything is looking fine, and based on the configuration I have selected, I may have got a IP address like this. See this. So this is a public IP address, and if this instance has worked as the way I expected and I was good with my user data script, if I open this, I should be getting a web page here which says welcome to AWS. Here is my web page. So what we did, we took a basic image, customized it as per our need, and then we were able to run it as a web page. This is one instance. I may customize it more and then make a template of it which can become a base for any new instance I launch afterwards. So that's easy to get started, not a complicated stuff. No need to install and go through operating system, and just go ahead and say what you need and we can get it sorted for you. Right now, let me show you some more information there. So when I'm selecting an instance type, I may want to select different instance type, and we name them little differently. This is how our naming system looks like. So the instance I selected to show you a demo was a T2.micro instance. So that instance was a T2.micro instance. This T2.micro first letter is representing the instance family. We may have an instance starting with T, may have an instance with C, another one starts with M, another one starts with R, and so many. So the first letter is an identifier that what type of instance it is, what family it belongs to. T stands for typical. Typical is a good combination of CPU and memory. It's not high on memory, it's not high on CPU, but it's a typical, a standard workload will work best when I'm having a T2.micro instance, so should not be a problem on that. If I'm looking for more compute, that time I would be selecting an instance family called C. So C says that it is a compute optimized instance and I am looking for higher CPU than any other component. So that's fine. M stand for multi-purpose. People understand it like it is memory. No, it is a multi-purpose instance type. Again, a good combination of CPU and memory. T is general purpose. We call it typical Tanu. So that is called typical. But yes, this is a general purpose type of instance which we are utilizing. R stand for memory optimized. It would be giving you a better memory performance. So select what your need is. So see this. If you see this picture here, we say that, hey, first letter would represent instance family. Second letter would talk about generation of the instance. CPU family, 4, 5, 6, that is the higher the number, higher the CPU family which is there, we can utilize that. And if your instance has some additional capabilities, they would be displayed in this particular format. So if I am seeing a letter here called D, I would say this machine or this instance type has some local disk associated with that. If I see here N, I would say this has some additional network capabilities associated with that. And this is basically the size of how much CPU, how much RAM. It's like short sizes. We would have XL, double XL, 4XL, 5XL. We should be able to utilize it. So last instance generation 6 is also there. So for some, we in some data centers or some locations we have C6 instances also. So just check for that. Right. So it depends on what it is. R is memory optimized. R is memory. You can think of as RAM, but we don't say RAM in our documentation. We call it is a memory optimized instance. So that's what we utilize it for. R stand for memory here. Memory optimized. Exactly. Okay. So these are my instance type. And you are not logged in. So I may start when I'm doing a POC, I may start with T2.micro. Once I realize it is working fine for me, I can say now let me move or advance it to become a C5 extra large. Or if I feel no, that will also not work, let me go with C5.24 extra large, which will give me hundreds of CPU and maybe a huge amount of memory available to me. So it's purely up to you. You can change them anytime, should not be a problem at all. Okay, so that's what my EC2 instances are. Now, EC2 instances are booting from a local volume. So let's see some of the storage options associated with EC2, that how we provide storage to my EC2 instances. And these are local storage which is being presented to EC2. So let me get started with explaining you the options available for EC2 storage. Okay. Now, EC2 is being in development from 15 years. So obviously there is no way I can cover every aspect of it. I'll try to cover the most important aspect and I'll give you some additional links so that you can reference it and learn more on that. Okay, let me draw that. What I'm discussing here, I am looking for block storage options for Amazon EC2. That's what I'm looking for here. I'm trying to explain those options to you. Right. Now, this is what my physical hardware is. So this is my physical hardware, right? Or I would say physical system. On this physical system, what I would be having on this physical system, I would have my Amazon EC2 instance running. So this is where your Amazon EC2 instance is running. Now people call it just instance, they call it Amazon EC2, they call it virtual server. They are some same name, but the concept is same, right? So we have instance here, physical system is running here. Now this system needs a block storage. Block storage is when we have to boot operating system or I have to install some applications. That time I would be needing a block storage for it. So operating system like your laptop needs a hard disk. Same way instance needs a hard disk. That's we call a volume. We have two ways to present a volume. This physical system, which is combination of CPU and RAM and hard disk, there are chances that this system also has some local storage available to itself, right? Possible, right? It is a server, so there may be some local storage associated with this instance itself. What we can do, and in some instances we allow that this local storage can be presented as a volume to my instance here. So that is a volume, a block created, and that block is associated with my machine here, instance here. That is one way. So what we did here, we presented a local storage to the system. This one is called instance store. What is instance store? It is a local storage presented to the EC2 machine directly from the server. That's called my local storage instance store. Now, this instance store, I would say, is limited in size, right? Because there is a limit of how many disks you can put into a physical server. So this would have a limited size associated with it. But another important aspect that this one is called ephemeral storage. I would say what is ephemeral? A fancy word to say temporary. So what is happening here? That This physical system is running fine, but what if this physical system crashes? Or what if the hard disk on the physical system crashes? Your data would be lost. So we don't recommend to keep critical components here because this one is being presented only from the local physical server. If the power goes off, if there is a hard disk failure, if there is a network issue, whatever could be, then your instance may lose the storage. So we provide this for temporarily. As soon as you shut down instance and start it, chances are that that time when you start it, this instance may be started on a different physical server altogether, and that time its local storage won't be available. So this is purely a temporary storage. So you may think, why I would use it if it is a temporary? Things like maybe you want to create a swap file, maybe you want to store some temp data before processing. In that case, this is a good solution, but this is not for keeping things permanently. So what if I need to store permanently? Then we give you something else which is called EBS, elastic block store. Let me draw that. Now consider that Amazon has a very big storage array, a storage array where we have lots and lots of disk available. And from that storage array, based on the requirement you say, we can carve out for you a volume. You say, I need 20 GB of space, no problem. So we can create a 20 GB volume for you here. But this is away from physical server. So we need to present this 20 GB volume, which is created on a storage array physically separate from my server to this instance running on this physical system. So what we need for that, we leverage network there. So what is going to happen now that we would be having network connectivity, right? The storage server is also connected on network. This physical server is also connected on a network, and we leverage network to send this block of data or make this block of data available to EC2 instances. So whatever the 20 GB we have created here for you, it is being presented to your EC2 instance here like a block volume. Technically, from where it is coming, technically it is going over the network interfaces. From that network interface of the server, it goes on to the actual network. From that network, it would cross, come back to your server here, and from here it would be connected to this 20 GB. So if you are coming from physical world and if you know about a SAN, it is similar to a SAN which we are utilizing. So AWS uses which storage array? Vishal, we say we would use a customized storage array, or we would say we were using a generic storage array. We do not want to say this is IBM, HP, or Dell. My guess is it's probably a system which we have developed on our own because the scale we are growing, better is to build things on our own instead of buying things from the vendor. So most probably these storage arrays are created by AWS. Maybe I'm calling them storage array. It may be a completely different system, right? So yes, exactly. So we design them. So this is the second way of storage which we have presented. This storage which I have presented here is called elastic block storage. Block storage. Or in the short form, we call it EBS, elastic block storage. So this block storage is a way where I can provide storage to my EC2 machine. Now this one is over the network. Do you see that? Answer is no. You say I need a volume and we will create it for you. I'll show you that in a minute. So we provide that over the network to you. Then this one is having variety or not variety, I would say multiple types. What I mean by multiple types, that you may say, hey, I am looking for SSD based disk. I am looking for uh, general purpose disk. I am looking for 3000 IOPS. I am looking for 200 GB of capacity. So there are multiple types and options available. You can choose from one you require. Plus this one is a permanent storage, right? See this, even if your physical server crashes, still your storage is kept separate, and I am showing 120 GB volume. Actually what will be happening at the back end, we will be creating multiple copies of your volume. We don't charge you for that, but my guess is that at least 3 copies are maintained for your data. So even if one of the disk fails, then you won't have a problem. So when I say a 20 GB is given to you, that doesn't mean that we have named a hard disk of 20 GB capacity and given to you. It's a system. And this system would have its own mechanism of snapshotting. It would have its own replication mechanism, but this is still kept within one facility. Amazon EC2 instances are created into a one availability zone, and your storage will be given from that availability zone only. So that's how we are providing storage to the application. So EBS and Instant Store. EBS is more common. You can use it for any operating system need. Maybe you are looking for a database to run, any type of operating system to run, any type of load balance, sorry, logs to store. It is purely up to you. And good part, on one single instance, you can say, hey, I am looking for one disk where I would be using operating system that should be of 10 GB, and I'm looking for 3000 IO from that. And I need another disk on which I am going to install a database, and that should be of 200 GB, and I am looking for, let's say, 5000 IO from that. So on the same instance, you can have multiple disk mounted, and they can serve a different capacity, different performance characteristics for you. So this is how we provide storage to your EC2 instances. Let me quickly show you how that EBS volume is created, and then we will take a short break before moving forward. So give me a minute. I would go to volumes and try to show you the volume section. Okay, hopefully everyone is getting. Does EBS do multi-attach across two or more instances? Anand, there is a specific type of EBS volume which supports it. But if you ask me a general question, I would say no, it is a one-to-one mapping. But we have a multi-attach EBS volume also, which you can leverage. But I would, in exam type of scenario, I would say no multi-attach. But yes, there is some instances supported, but it's not generic. So see this. I am here on to the volume section, and I can go ahead and say I am looking to create a volume. I would select what type of volume I'm looking for. These are different characteristics. GP2 stands for general purpose, IO1 provision IOPS, IO2 cold. These are the different characteristics. And good thing is, click on this icon or select it, and it will tell you that what maximum minimum size that particular disk would support, how many IOPS that disk would be supporting for you. So this is a good way to understand. So see this. If I select SC1, I can go from 125 to 16384 GB. But if I'm selecting, let's say, IO2, then I can go up to 65,000 GB and this much IOPS. So it depends on what you are looking for. Let's say I create a GP2 volume. I have to specify the size of it. I would say 10 GB volume, and I can put it into EU West 1A availability zone, and I can add some encryption if I need to, or I can add some name. So let's add a name, call it 10 GB GP2 volume. That's what I can select and say create volume. So what happened now? One disk has been created for me, one volume has been created for me, which is 10 GB. See this one. But currently it is not connected. See this. What I see here, if I scroll further, this one says in use because we connected this to the instance we launched. But this second one, 1A, is not connected as of now. It is available. So once I have a volume created, I can go ahead and say, okay, what I want to do with this volume now, I want to attach this to a volume, and that time I could attach it to the instance. This is my BeSA web server, and I could attach to it. Now, here is one important thing which you have to remember. Let me draw that on whiteboard so it would be easy for everyone to follow along. That is very important thing you have to remember. These volumes, when you are creating, they are specific to a availability zone. Let me explain what I am trying to say here. Give me a minute. I'm opening up the paintbrush here again to explain you things. Okay. All right. Now, if you remember our first day discussion, we talked about that there are regions, right? So this is what my AWS region is. Now, regions would be made up of what? Regions would be made up of availability zones. So we have availability zone 1 here, availability zone 2 here, availability zone 3 here. When you are creating a EC2 instance, EC2 instance is AZ specific. This is created into a availability zone. So this is where my instance would be created. And the EBS volume of that should also come from the same availability zone. And it makes sense. You don't want a volume to be coming from a very distant storage location because the performance would not be great. So EBS volumes are presented into the same availability zone. Now, if you have another instance which is running into another availability zone like this, you can't present, you can't say that, hey, let me disconnect the volume from here and attach this to this EC2 instance here. It won't work. So volumes can be attached into the same availability zone, not beyond it. If you need to do that, you need to do one more stuff there. That is called take a snapshot. We support snapshot of the volume. And once you take a snapshot, snapshots are a regional entity. Snapshots are regional. So when you take a snapshot, it is stored into region, not within specific availability zone. So this is where my snapshot is getting created. I have taken a snapshot from a EBS volume. Later, I can use this snapshot to create a volume into one availability zone or second availability zone or third availability zone. It is purely up to you. Even snapshots can be copied across availability zone, sorry, across region if you want to. So that is possible, but a volume is a AZ specific entity, whereas a snapshot is a regional entity, right? Hopefully everyone is following along and understanding things. Now, one more important stuff which lot of people do not get, let me explain that stuff also. Let me explain that. Let me give you an example here to explain things. Let's say we are saying that we are having London as a region. London region is made up of three availability zones, right? So there is three availability zone, let's say AZA, there is AZB, and there is AZC. Three availability zones are there into London. For sake of discussion, let's say AZA is in Southeast London. Just give me an example. Maybe let's say AZB is into North London, and then maybe AZC is into West London. Just give me an example. Now, chances are that when I have to make a selection, like if you remember, I haven't selected AZ for myself. When I selected a EC2 instance, it auto selected AZ for me. But most of time customers start, they may make a selection and it may happen that AZA is where 90% instances are running. Nobody is using AZB, 20% instance running, and nobody bothered to put their instance into AZC and only 10% instance are running. This kind of uneven distribution may happen, right? We don't want that to happen because then you are having a bigger impact and we cannot manage capacity because AZA would be always utilized high, nobody using B and C, so that's not a good distribution of services. So what we do in that case, we randomize these on account level. So let's say that is account A here and there is account B. I'm saying account, this is I'm referencing to a AWS account. Every AWS account has a unique ID to identify that. So these are my AWS account and B. Now, AZA of account A, AZB, and AZC will be different from those accounts. Let me show that what I mean. So for you and me, it would look like if I'm logging in, it looks I am connected to AZA, but it may happen that your AZA of account A may be pointing to north, your AZB may be pointing to south, and your AZC may be pointing to West London. And then your AZB here could be West London, AZA could be North, or AZC could be Southeast. So these randomization is done for ensuring distribution of capacity properly. Now you may see, hey, why I should be worried about? Let me explain. Let's say you have a two-tier application on what you are looking for. You are looking to install a web server and you are looking to install a DB server. Web server would be installed by account 1, account A, and DB server will be installed by account B. Now, it's a purely physical system that if you keep them as near as possible, they would have better performance. Now, I say let's deploy things in AZB. Okay, so I say AZB means my web server would get deployed here, which will be AB North. Now, this account AZB is West, so they think they deployed in AZB, but it may end up into West London. and they can still communicate, but obviously performance would be little degraded because we are talking about miles distance between these availability zones. So how I can mitigate that? We give you something called AZID. So AZ name is AZA, AZB, AZC, but you should make your decision based on AZ IDs, and I can quickly show you how you can find AZ ID associated with your own account. So that can be something you should be aware when you are deploying across multiple accounts. So let me go to something called Resource Access Manager, and there you can find that information. And there are multiple ways to see that. I'll talk about that when you create networking also. That time also you can see it. So I am now going to Resource Access Manager, and I would be able to see what is my distribution of account, sorry, my distribution of availability zone, and your distribution within your account would also be different. It is purely done to ensure not creating any hotspot and to equally distribute your workload across different availability zone. So I'm coming to Resource Access Manager. See this thing here? What you're seeing, my 1A is actually AZ3, my 1B is AZ1, and my 1C is AZ2. So AZ name and AZ IDs are two different things. Don't be confused with that. AZ name is basically identification, which is user friendly. AZ ID is the actual anchoring to the location of that system, right? Everyone okay so far? Hopefully everyone is understanding and getting value out of this session. So I think it's a good time to take a short break, and once we return from the break, we will then talk about more interesting stuff. I'll talk you about some storage options. Sorry, cost option. So we already discussed what is my local storage, what is my ephemeral volume, what is my EBS block volume, and you would be getting these slides as a PDF format. So it would be available, and you can select specific EBS volume. They are specific to AZ. It can be expanded but can't be shrinked. Support snapshot attached to single EC2 instance and support encryption also, right? So let's go ahead and put a 5-minute timer, and once you return we will then discuss more interesting stuff. I'll put a timer and I'll talk to you soon. Thank you. About the remaining stuff, we will talk about how the pricing options work, because obviously at the end we need to be aware that what choices I am making, which is keeping you cost afloat and helping company in keeping the cost low. So I am talking about EC2 instance pricing. There are multiple ways to price the instances and to use instance depending on your use case. So let me explain them by an example so that you can relate it. Now, I would divide this into four categories: on-demand instances, reserved instances, savings plan, and spot instances. These are the categories of purchase. If I'm looking to buy a EC2 instance or get a EC2 instance, these are the options which I have. One is related to on-demand, reserved, savings plan, and spot instances. Let me explain them one by one. And I have listed them in their highest price to the lowest price. Highest I would pay in on demand, lowest I would pay into spot instances. Let's go ahead and talk about it. Now, I would give some examples here again to explain you things in easier fashion. Taxi. Let's say you come to London Heathrow. From there, you have to go home. One option for you is that you can take a public transport, or if you have a lot of stuff and luggage and you want to go to a specific place, probably you are looking for on-demand taxi. You would book a Uber or you would hail a taxi and get into it and go to your point. That's all. In that taxi, you are paying from point A to point B. You do not worry about taxi insurance. You do not worry about salary of the driver, or you do not worry about the maintenance record of the service, maintenance record of the car. We expect when a service is being rendered, they are already fit. They have taxation done. Their driver is trained and all the stuff. So that's what I'm doing. Highest price I'm paying, but that is good because I have a use case only for going from point A to point B. I do not want to use it further. So that's what money I would be paying. So Uber taxis and any other taxi you use is on demand. On demand in EC2 is called a on demand pricing tier, in that what you do, you pay by second. So if you start a machine, like I have started a EC2 machine, and if I run it for 45 minutes, I would be paying only for 45 minutes. If I run it for 60 minutes, I would be paying only for 60 minutes. Once my work is done, I would be removing it. That should not be a problem at all. Right, so that is called my on-demand pricing, where I pay by second for Amazon Linux and Ubuntu and Windows instances. And if there are other operating systems, sorry, give me a minute. If there are other operating systems, in that case, what I have to do, one moment, please. In case of other operating system, I pay by the hour. What I mean by the hour, so in that case, I would be paying, let's say if I use that instance for 60 minutes, I would still be paying for 1 hour. And if I use that instance for 61 minutes, I would be paying for 2 hours in that case. So let me start this again. Sorry for that. Yeah, my PowerPoint sometimes doesn't work as expected. I'm trying to refresh it again. One more minute. Yeah, it's not working as I'm expecting it to do. And it is not allowing me to close PowerPoint also. It's need to happen, I guess. Trying it one more time. Sorry for that. I had to kill point. Okay, I'll open again and we'll start from there. So I was explaining on demand, like a booking a taxi. So in taxi, you do not worry about nitty-gritty stuff. You need a service, we give it to you. You pay for what you use. That's all. Afterward, whether the taxi require that much of maintenance or how much petrol prices are, you do not worry at all on that. So on-demand instance type is good when you have a very specific use case and keep your application running for a small amount of time or for undefined time period. That time, I would prefer to go with demand instances. So in this case of on-demand, what I would be doing, I would be paying by second. And if it is a other operating system, I would be paying by the hours in that case. So if my workload is unpredictable, I do not know how long I'm going to keep this service running. I'm just doing a POC, doing a testing. I have no long-term plan to keep the service running. That time, I would be going for on-demand instances, right? I think you are running low on the CPU. Your sound is also breaking. Alex, could be. Is it okay now or is it still breaking? Now, okayish, all fine. Yeah, maybe I had to reduce the resolution next time. I would be keeping low resolution so my CPU doesn't heat up. That's what is happening as of now, I think. Thank you. Now, on demand is good for unpredictable workload. Let me talk about reserved instances. Let's say you decided that you are going to come to London and stay there for 2 years. Now, what you would do in that case? You won't be hailing taxi every day or calling Uber every day. It will not be very economical, first thing, and it may not be available when you actually need it. So what you can think, hey, let me think about leasing a car. It's a very common. Middle East, very common to lease a car. People come there for a project work for 1 or 2 year or maybe 6 months. You can go and lease a car there. When you lease a car, the car is with you whether you use it or not. Right. So that is what a reserved instance is. You go to Amazon and say, hey, Amazon, I am going to use your instance for a commitment of 1 or 3 years. I want to ensure I am going to use your instance for 1 or 3 years and please give me better price. Like when you book a hotel for 5 days or you book a hotel for 5 months, obviously you can negotiate a better price or hotel would have a different pricing for long-term rental. Exact same thing happens here that when I am reserving an instance, that time I am making a commitment for 1 or 3 years and Amazon would be giving me a better discount in that case. Now, when I should reserve it? I would reserve it when I have a use case for long running and a predictable performance. If I know I am going to use a C5 dot extra large for next 1 year or next 2 year, then it makes sense to reserve an instance. So when you are leasing a car, you have to tell what type of car you are looking for and how long you want to rent it so that we can give you better pricing. So that's what reserved instance is. So this one is where you say what type of instance you need, what operating system you need, which region you want to reserve it, and what availability zone you want to reserve it. So this is called a reserved instance. Now, here is a commitment. Whether you use it or not, you are still paying the money. You rented a house, you stay it or not, or maybe that is whether you are using that house regularly or not, you still pay money on that. That exact same thing happen with reserved instances. Now, people think that when somebody reserves an instance, Amazon blocks a physical server for them. Answer is no. Think of reserved instance when actual utilization happens, you get some discount. What I mean by that? When we do shopping online, we may have a coupon, let's say 10% discount coupon. So you put whatever stuff you want into your shopping cart, and when you are checking out, you apply that coupon, and that entitles you for 10% discount, right? That exact reserved instances. So in reserved instance, you would be getting a discount added at the billing cycle. It's not like we put a physical server, added your name, and you would use only that server. It is a capacity reservation. It is not a physical reservation, right? So make sure you understand it that it is a capacity reservation and it is a billing discount, but it is not a physical reservation which is being done for you. So that is called reserved instances, and it is good if I have a 1 year or 3 year commitment to make. Now, if you made that commitment, let me explain that. So what you did, you made the commitment. You said, I am going to use a C5 dot extra large instance and I am making a 3 year commitment. This one will be used into Ireland and I would be using a Linux based operating system there. So this technical commitment you made. What if your requirement changes later? What if your company decide that, hey, we do not want to use Ireland anymore for region, we will shift everything into London, but your reservation is into Ireland. So this money you still have to pay because it's a commitment. You are committing to pay that money whether you use capacity or not. Why? Because based on the commitment you had said. So if you said Amazon, we are going to use 1,000 instances of this capacity. So Amazon will make investment on your behalf to ensure that we always make that much of capacity available to you. We keep this much service and servers available for you. So there is an investment being made on your behalf on Amazon, and that's why you have to get committed there. That is reserved instance. But as you can see, I have to be very thorough in my choice. What if my requirement change later? So we realized that, and then we came up with a reserved instance plan, sorry, savings plan. I personally call reserved instance 2.0, RI 2.0. It's not official term. I just use it to explain that whatever challenges customer faced here in reserved instance, we tried to solve that by launching a feature called savings plan. This is a relatively new feature. Let me explain a savings plan. Again, let's take a car example. Let's say you you lease a car and your lease provider is flexible. Lease provider says, hey, when you need a car, you make a commitment. Let's say you will pay me $300 per month. Just give an example. And in that $300 per month, you may take either a car or you may take a bike when the weather is good and you want to go for a bike ride, go for that. You are doing a house shifting and you need a bigger vehicle, or you're getting a lot of luggage or buying something from IKEA, you want to get something else, you can lease a bigger van from us. So this commitment you are making and paying to us every time. If you use the van and that month your bill came to 400, you pay extra 100 to me, but this is a commitment price you are paying to me. So here we have flexibility. Flexibility in terms of which vehicle to use. Same thing applies on saving instances, that what happens here in savings plan, we give you a commitment of fixed payment. You say to us, Amazon, I am going to pay you $10 per hour for compute. And in savings plan, we have option. You can say, hey, will you use this $10 per hour for EC2? If yes, you can book that. Or if you feel, no, my request can be for EC2, or I may want to use Lambda for that $10, or I may want to use container for that $10, we don't mind. So that is giving you flexibility that you may change your mind and you may say, I would use Linux today. Tomorrow, I would be using a different operating system. I may be using a different region, so that you can configure into savings plan. So it is giving you more flexibility, and your commitment is based on the type of the reservation, not on the technical commitment. You are paying for a fixed type of payment. So this is a payment reservation, and flexible in terms of reservation. You may decide to change it. That should not be a problem. So that is called my savings plan, which I call reserved instance 2.0. All right. So hopefully everyone is clear. Third one, sorry, last one, fourth one is called spot instances. Let's say, let's say we visit a place, right? Let's say I am going to Amsterdam. Just give me an example. I go to Amsterdam and I have to use a car there. Now, my friend lives there, and I can say, hey, if you are not using a car, can you give your car to me? If she is not using the car, she would be happy to give that car to me. And in that case, I have to take care of only of the fuel. I have to obviously take care of that it is clean and all the stuff, but I am not paying too much money on leasing, or I am not making a long-term commitment. I am using my friend's car for my usage. But there is a limit, there is a catch. She says that, hey Ashish, I'm not using my car as of now, but sometime my office calls me, or maybe I have to do a school run, get my kids from that particular place, and that's why I would call you 2 hours before. So if I call you 2 hours before, please make sure that you return car to me so that I can go and do my business. Hope you're getting the point. So yes, I can use the car as long as she doesn't need it, and if she needs it, she would give me a call, and I should be able to return the car, because that's what a commitment I'm making. Same thing is in spot instances. Let me explain that in now technical terms. In Amazon data centers, let's say I am talking about London. So in London, there are possibility that we have 50,000 servers running. Just give an example to you. Let's say we have 50,000 servers running. I don't expect that all 50,000 will be always being consumed every time. So maybe out of that, 35,000 servers are currently being consumed, and our customers are using that, which means we still have 15,000 server capacity available for someone to use. These servers are still running in our environment, consuming power, consuming electricity, and basically not generating any revenue. So if these 35,000 servers were given to the customer, let's say on $2 per hour price, we may say, let me give these 15,000 server on a zero point 0.1 per hour, $1 per hour price. I am giving you a discount. So if you want to use these servers, you are welcome to use them. They will be categorized as spot instances, and they are basically based on supply and demand pricing. So if we have lot of service available, lot of free resources available, cost would be cheaper. But if the service is highly utilized, cost may go up if there is a high utilization of those services. But still very cost friendly for workload which are having no problem in running in this fashion. So that is called my spot instances, and I'll show you some example that how customer use these spot instances. So spot instance is what? Spot instance is basically unused capacity of AWS. And that capacity can be given to you. But remember my notice of getting the car back in 2 hours, same thing here. But here, the notice which is given to you is for 2 minutes. So supply and demand based pricing, if Amazon need those instances back, it would send a notice to that instance and, hey instance, I am going to pull you back in 2 minute time. So the 2 minute notice can be given to instance. If Amazon needs that capacity back, they would claim back that capacity. Now what I should do in that 2 minute? First thing, probably I won't be running most critical application on spot, because it may be taken back from me. right? What I would also do that I would be probably hosting my data on some other location, maybe a database, maybe a S3 bucket, maybe a DynamoDB table. It could be anywhere. But I probably won't keep my data within instance because my instance may get terminated after a 2-minute notice. And that's why it's better to keep data somewhere else. So if this instance gets terminated, no problem at all. Later, I can launch another instance and that can pick up data from here and can start processing that data. So that is called my spot instance, supply and demand based pricing. But there is a 2-minute notice which may be given to you, and you may have that instance claimed back. So don't put your highly critical applications there because it is not designed for it. So what you can do, there are multiple ways to use spot instances. Let me give you an example. Let's say you are requiring 80 instances. Just give an example. You can say, let me take 20 of these instances from on demand, or let me take them from reserved instances, and remaining 60 I would be taking from spot. What happens now? These 20 would never be taken back because I am paying full money for that, or I have reserved it. So they will never get back, be taken from me. 60 may be taken back from me, but it won't affect my application because still I have 20 running permanently. Same way, like people or companies hire temporary employees, isn't it? Right? Like if I talk about Amazon, when there is a Prime Day or there is a Christmas sale, what we need lot of people in our warehouses. We need lot of drivers who could deliver the packages from Amazon because there is a huge demand. But we can't hire all these people for 24 by 7 and 12 hours, 12 months in a year. So what we do, we hire some temporary worker that time. They help us with 2 3 weeks of whatever cycles we have, and then they go to their day job, and we still have some permanent employees who will be always in warehouse. And when demand grows, we hire temporary workers. And exact same thing you can do with spot instances. All right, hopefully everyone is going to get the idea. Let me explain a little bit more on the console so that you can relate to the stuff which I'm talking about. So we give you a spot instance advisor from which you can get all the information, like what kind of discount, what is the predictability of downtime. That information is available. Let me show that to you. So I'll go back to my service EC2, and there I would be talking about spot instances. So spot has very specific use cases. If you could smartly use your EC2 spot instances, you would be saving huge money. There is at least 70% discount which you are getting on that. Let's go ahead and see that. So this is my EC2, and here are my spot request. See this example here. So I go to my spot request and we'll see what my spot requests are or what I can get from there. Let's go ahead and check the spot request. It would show me the price difference, and it would show me what is my current availability in that particular region. So this is my spot request. I have here saving summary, and we maintain a pricing history of old 3 months. So let's go to pricing history here. Now, if you see, there is a graph we are maintaining. So I can say, no, I am looking for a particular instance type. Which instance type? See, I am into Ireland region, and I am selecting a particular instance type here to get its historical information about the service pricing. So let me go ahead and select a instance here, which is, let's say, C5 dot extra large or something. So let's say C5.18 extra large. Okay, this is my instance. Let's see pricing difference. So see these three availability zone, 1A, 1B, 1C. I am checking for date range 1 week. Let me make it 3 months. So we maintain 3 months of data. And you can see huge graph here. What would be the difference between the pricing here? See this. See this. What you are seeing here? You are seeing C5 dot extra large, and this is what you would be paying if you are utilizing these services, right? So $1.335 C5.18 extra large, C3 dot extra large. Let me remove this one so that we see only one. So that is my C5 dot extra large, which is into EU West 1, which I would be paying for. So this is the money I would be paying, and how much saving I would be getting because of that. Around 60% saving I would be getting. Let me bring it up again. Probably I closed it by mistake. So let me bring it up again. See this. So let's say if it is C3 dot extra large, if I pay on demand, I would be paying 0.12. on demand price. But if I use it on spot, I would be paying 0.0347, and as you can see, it's 70%, 74% discount, and it is for 1 week. I can push this data and identify for 3 weeks, 3 months. So that would give me that, hey, what benefit I may get. And if you see, there are some variation here in the graph. Why? Supply and demand. Now, if you see, even in 1A, 1B, and 1C, pricing are little different. See this. This one is charging you 0.344. These are charging you 0.0312 and 312. So I would say, I see there are more instance or capacity available in 1A, 1B, and 1C. There are little less capacity available into 1A as of now. So if I have to be little safe, I would probably go for 1B and 1C and run my application from there. So that would be my way of looking at the things. So that is what is called a spot instance. And customers are very smart. Customer use spot instances in very creative way. Let me show you one of the use cases from Illumina. It's a company who is into genome processing, and they use instances for running their workload. Let me quickly walk you through what their workload is and what they do. So this company is doing, and I will send you all these links, so don't worry. This company is doing lot of genome sequencing and processing, and for that they require lot of capacity. So what they do, they say that, hey customers, we would be offering you two type of services. Select what feels best for you and what you want to use it for. Let me give an example for that. So let's see one example here. They offer two type of services. Just an example, read more in detail there. So let's say one is your standard service, and there is a express service. Standard service says that once you submit your sample, maybe you would get your result into 14 days and you would be paying this much money for that. Express service says when you submit your sample, you would get your results into 2 days and you would be paying more money because you are looking for performance, which is you are looking for faster turnaround time. Now, what they do, they have two pool of instances. One pool of instance or group of instance is made up from spot. Another pool which is made up of on-demand or reserved instances. Obviously, in spot instances, they would be paying less money. In spot instance, on-demand instances, they would be paying more money. So as soon as a workload is submitted, so let's say this is a workload submitted. Now, workload starts, maybe 10% of that workload was finished by one instance, then it got claimed back. So they store that information somewhere. Afterward, they launch another instance automatically, which would start again. And maybe this time, this instance was able to pick up the workload and finished up to 40%. That instance also got terminated. Let's have another instance running that may then pick up the workload and maybe finish it up to maybe 65%, and so on. So what is happening, as they are getting charged less because of spot instances, they are able to transfer that benefit to their customer. So if they are not time bound, they can wait for 14 days, go ahead and use spot instances for that type of workload. But if a customer says, no, I want my processing to be done faster, that time they push their workload onto on-demand and reserved instances, no termination, continuously running off the workload, and they get their result much faster. So that is one of the use cases. You can smartly design your application. One more word we commonly see people talking about whenever they discuss spot instances, that use this for stateless application. Why stateless? Because if you are storing something locally, that instance may get terminated. So best would be to store it somewhere, store your state information somewhere outside. So if this one was going to be um, changed, then that time this information is stored here. This instance gets terminated. This can pick up, update it again. If this get terminated, this can pick up and store it again and start it again. So this is good when you have a stateless application running into your environment. All right. So hopefully everyone is now clear a little bit more on what is actually happening and what are my EC2 instance options. All right. Obviously, I can't cover everything, but hopefully you got a better idea on it. And if you have any other follow-up questions, feel free. We would be sending some resources and you can take help of those resources and more knowledge to understand how all other EC2 options are available. Okay. So that's all I wanted from my side. Now, we still have 30 minutes, and that is the crucial 30 minutes for a lot of you. Let's talk about it. Okay, one more thing before I move forward. What I am also going to share today will be these type of summary cards. So in this summary card, you would be able to get more information like what, why, when, where, who, how much. So I tried to put all the information which is relevant on one single screen, one single service card, and would be shared with you on the BeSA web page where you can get it, download the PDF, keep it with you, read it, and ask any further questions if you have. Okay. So now I want to ask my colleague to help you with some real life use cases along with these instances. So what we are going to do now, we are going to talk about the use cases for Amazon EC2. And Crystal is going to help us today. She has created, she will be walking us through a POC and will help us to understand how that particular works. So Crystal, if you are up, please share your screen. I'll add you to the stream and we can get started from there. Give me a minute. Yeah.
Hello.
Crystal, I added you to the stream.
Yeah.
And if you have a screen share, or should I walk it through?
I'm sharing my screen. Can you see this?
Okay. Nope. Still no.
Okay, right.
Give us a minute. Still. Yeah, it's coming up. Give me a minute. I'll add it.
Okay. How's that?
Yes, you're good. Thank you.
Perfect.
Move
Okay.
forward.
I'm conscious that my colleagues also have things to share, so I'll try to be brief on that one. But basically, what I want to show with you, to share with you, I want to ask you to put yourself in the role of an architect, and we're going to use a use case, very easy use case, and we're going to consider some very important factors for a solutions architect. These are things that we have to keep in mind when we design solutions for our customers. Okay. So the use case is pretty simple. We are working with an architect in a school, and what they want to do is to host their one of the catering service website on AWS, so that students can actually they can check the balance to know how many meals they can buy for the rest of the month, and they can also top up their card. So something super easy, and we're going to go on a journey of a solution architect to kind of build something super simple for that. Okay. All right. So we've got the AWS cloud. We've got one availability zone. We have our students there. They want to top up. So you've just heard about the EC2 instances. That's a great place to actually run our websites. Now, basically, what we could do here is that we can just provide direct access to the website for the students. But there's a lot of things that we can do here to actually improve our architecture. Now, I'm adding a database here. We haven't covered databases for now, but basically, when our students are basically accessing the website, they are going to store some data. There will be data stored about how much left they have on their cards, how much money, their name, their last name, their student number, the card number. We're going to put all of that data in a database. Okay, so that's just the reason I put a database there, but it's not the focus for today. Okay, so first thing we have to think of when we design architecture is security. If we provide direct access to this for the students to the website, if we want to think about how can we make this access as secure as possible, so that's students can connect safely and nobody can see what they're doing. They're putting their card details. It has to be hidden. So one thing that we can think of to actually improve the security of this design is to add encryption in transit. So see, when you go on the internet, you see this HTTPS, right? And then you put your website. The S is for secure. So we're going to use some mechanism within Amazon Web Services to make sure that this traffic is encrypted. So when the students actually go and top up their card, nobody can see what they're doing. This traffic is completely encrypted. Okay, so that's the first layer of security we can think of. Now, all of the students, they can put their card numbers and what are the student card numbers and basically their access to the environments. Wouldn't it be nice if they had actually a way to log in so that they have their dedicated accounts there? So another thing that we can think of here is to add an authentication layer that is going to allow our students to put their credentials, to log in, and to have access to their dedicated profile, okay, where they can do all sort of stuff. So these are two quick ways that we can think of to improve the security of this design, and we have already made one improvement. Okay, super easy. Now, let's move on. The next thing is reliability. When we design, we have to think about worst case scenarios. What happens if the servers crash? Unfortunately, this is what happened to us. And sadly, we only had one instance. So that was a single point of failure here. That wasn't good design. So what we could have done, actually, is to have deployed another EC2 instance where that also has access to our database, so it can retrieve the same data that was actually stored from this initial server, so that if this instance is no longer available, then the second one is going to serve our website. It's super important for the IT person in the school that they can provide to the student something that is highly available. Now, the question you might ask me is, if there are two servers, how do the students know if they should access this server or this server? Actually, they don't know, and they don't care. So we need to find a way, we need to find a mechanism to actually have something that is going to balance the request towards, the servers that is online and not the server that is not online. So what we're going to use here is actually a load balancer. Now, I'm not diving deep into the AWS services that do that. I'm just showing you some concepts that work with your EC2 instances. So this load balancer here, its job is going to take all of the requests from the students, and then it's going to direct the traffic to the available server, okay? Now, once our other server comes back online because we've connected, we've fixed the issues and so on, maybe what we can decide is actually to split 50-50 traffic between our two servers, so that we actually spread the loads between our two servers. So one is not too overloaded compared to the other one. That's one of the ways we can design that. There are other ways, but I'm just showing you what is possible here. Okay, so now we have a design that is secure. We have a design that is highly available. So our students are pretty happy. But because this is this website here is actually to top up the lunch cards. So what happens is that at the end of the month, all of the students, they connect all at the same time, and we're having some performance issues. They are complaining because it takes 5 seconds for the page to appear. Sometimes they get some timeouts. Sometimes it just doesn't go through. So another thing that we have to think of as architect is performances, also during peak time. So end of the month is a peak time. Everybody connects at the same time. Performance are impacted. How do we fix that? One way we can do that, we can actually deploy many servers, right? That's good. It's going to cost a bit of money, but if we only need to have more instances at the end of the month, we're going to be paying for these extra resources, for an entire month where we're not going to use them. We're going to use them maybe for, I don't know, 7 days of the month. It's not good best practice here from a cost perspective. What we can do instead is to think of auto-scaling capabilities, where we are going to tell our EC2 instances one condition. You are going to add +1 server when our servers are reaching 70% CPU utilization. So we're going to give the condition to add extra resources. So now what's going to happen is that at the end of the month, when all the students are connecting at the same time and our servers are reaching 70% CPU utilization, another server is going to get deployed, okay? And same on the other side. All right. So now we have a design that is secure, we have a design that is highly available, and we have also taken performance into account. Now, if we want to push this a little bit further, we can use 2 availability zones, for example. There's a lot of things that we can do, but I just wanted to share the 3 aspects that we always consider as architect: security, reliability, performance. There's one more that I could quickly share before I transition to my colleague. It's operations. We don't want to be manually changing stuff all the time. One of the ways that we can reduce our time managing the infrastructure is to use AWS managed services, for example, or we can use serverless services, or we can use infrastructure as code. These are basically mechanisms that help us to spend less time doing manual improvement on the architecture, because the more you scale, the less you want to be manual on your architectures. If you're too manual, you can get into troubles for actually making mistakes. So you really want to improve your operations or your design skills. And next week we will talk about VPC, then we will talk about databases. I think it will be good if we can show you, things, how to operate things at large scale. So that's all I wanted to share. And I hope I didn't take too much time, Ashish, and I'm going to transition to my colleague, Prasad and Jamila. Thank you.
That was interesting, Crystal. No, you didn't take more time. We can always adjust, and people are here to hear, so it's okay. And as long as the message get conveyed. So thanks everyone, and thanks Crystal. Now I will add Prasad and Jamila on the stream, and they would help us in a common question which we all get, like, hey, how I transition from a non-tech domain to a tech domain? That's what we are trying to understand here. So let's go ahead and talk about that question. So over to you, Prasad and Jamila.
You are on mute, Prasad.
Still, Prasad, I can't hear you.
I think we lost him.
Yeah, okay. No, let me add him to stream again. Prasad, can you hear us?
Yeah, I can hear you guys. Can you hear me?
We hear you now.
Perfect. Cool. Okay. Thank you, Ashish, for a great presentation, and thank you, Chris, for awesome reference architecture. Me and Jamila will be talking more about how to transition from a non-technical domain to cloud. And in fact, let me share my screen, and I'll share a few LinkedIn posts that I have made in the past, and then I'll talk about a step-by-step process. We'll see how much time we have to cover this week, or we'll continue
Prasad,
the same discussion next week.
Can I ask you one thing? Can you introduce yourself? I forgot to ask you to introduce. Everyone knows Jamila now, but you are first time, and I would ask a little bit to know about you so that everyone is aware, like who are you and what you are doing in AWS. Thank you.
Sure. Yeah. So I'm a principal solutions architect here at AWS, focusing mainly on Microsoft workloads. So my day job is actually helping partners in enabling them in migrating and modernizing Windows workloads onto AWS. Apart from that, I do a lot of mentoring. I have been mentoring a lot of people to transition to cloud for quite some time. I do keep sharing tips and tricks on the LinkedIn about if you would like to transition to cloud, or if you like to get started, or if you would like to get interviewed and crack AWS interview. That's a quick background about me. From the background perspective, I come from a .NET development background. I started my career as a .NET developer and then moved on to become a solutions architect. I did consulting for a lot of time before joining AWS.
Nice, thank you. Now, if you could share the screen so I can put it on stream so that everyone can see it.
Sure. Let me share my screen.
So Prasad was shying away from camera for a long time, 2 weeks. We were able to drag him this time.
Yeah, I love to be in background. Anyways, I was I was traveling a bit, but yeah, it's good to be speaking to so many guys. And thank you all for being so engaging on the chat. Love it, actually. But yeah, going back to the topic of if you would like to transition from a non-technical role to the cloud roles, so, like I do have a 10-step playbook, and I can share this link, the LinkedIn post link again, but it's a kind of, a step-by-step guide for you guys, like whether you are from a non-technical background or from a non-cloud specific role, want to get into cloud, then you can follow this, and hopefully it will be helping you in transition. But I'll be sharing stories of 3 people today, and we will be hearing from Jamila live about how she transitioned from a non-tech to tech. So the first example, and again, as I said, I'll be sharing the links later so that you guys have it handy. So the first is about Daniel. He actually dropped out of college, and he worked as a bartender and taxi driver before thinking about moving to cloud. So you can
Prasad,
think about.
can I ask something? Can you zoom in a little bit so that it would be visible? It's like zoomed out. Yeah, this is much better. Exactly. Thank you.
Okay, cool. Thank you. So yeah, this is the story of Daniel. He moved into cloud from not having any technical background, from dropping out of college to working as a bartender and a taxi driver. He thought about becoming a cloud, and he works as a cloud engineer, cloud advisor. Right. So like during the pandemic, he quit his job as a taxi driver, and then he actually started studying for AWS Solution Architect Associate. Within 4 months, he became Solution Architect Associate, and then CISOP Associates, so on and so forth. What helped him, apart from studying, is networking a lot on the LinkedIn and applying to too many jobs. It's not going to be easy if you're like coming from a non-technical background, but if you have that grit, you will be able to get through it. And the opportunity came through LinkedIn. Like he used to regularly share his like progress. So this is what I always tell people whom I mentor, that while you're learning, share your learning on the LinkedIn, right? Any project that you're doing, do share it. You never know who is watching you. Network with a lot of people and keep sharing. Like live examples like Daniel, like seeing his progress, a CEO of a security company approached him, offering him an interview, and he got hired. Like he started, let's say, in April 2020, and November 2020, he had a job in hand, right? And then obviously it will be a learning curve, right? And he kept, achieving more and more certifications, and now he's helping startups in their AWS journey. Similarly, let me zoom this again. Fabrice, right? He was a veteran, becoming an electrical engineer in manufacturing, so not from an IT background. And he was able to get his first role at Accenture as a cloud DevOps engineer. And there's 8 steps, what exactly he did and how he was able to grab this role. And you will see that, apart from studying, the self-study that people has to do, they can always leverage the network. My LinkedIn Cloud Network expanded. I'll start following, connect more people, and it's more about keep connecting and keep sharing your knowledge. That's one tip that I always tell them. Other thing that I loved is that he wiped out the Windows old laptop and put in Linux, and he started from scratch. So that also helped him. That's what he told. Yeah, so that's on. And finally, yeah, we do have 10 minutes, and this is where I'll ask Jamila to come into picture and share her story. I got inspired by Jamila a lot. I knew her even before she joined AWS. I know her journey. It's too inspiring. So yeah, Jamila, take it away.
Thank you very much, Prasad. Well, as some of the people already noticed, and they read your LinkedIn post, so thank you for that. I'm an economist. I have no technical background before joining AWS. So the important few key takeaways for me in this journey was that identifying where I'm standing currently, where I want to head, and what I'm lacking. So it seems as easy questions to ask, but when you actually step back, look at it as a big picture and put a timeline that, okay, I want to be there, and why I want to be in that position or in that company, what inspires me, what ignites me in this role. So as Prasad mentioned, I know Prasad before joining AWS because I was networking on LinkedIn. I was adding people from AWS, and it's not because I wanted to bug them, especially Prasad. It's just because I wanted to understand in the future when I joined the company, and I had the feeling that I will join the company, and I had that kind of little bit of confidence deep in my heart that one day I will be among them and I will be their colleague. And I wanted to understand their way of thinking, their mentality, their way of working. And someone in my network shared Prasad's post about mentoring, about Solutions Architect Associate exam and preparing for the exam. And I applied. I was like, okay, I don't have any technical background, but I want to learn, because I have some other skills, like I have data analysis skills. I know a little bit of programming here and there, and I wanted to dive deep. And solutions architect's role, I thought it will fit my personality and my career goal in the long term. So I added Prasad to my LinkedIn connection, and I applied for the program. But the interesting thing is that I didn't get admitted. So as many of you probably did and currently doing, that's what I'm seeing on LinkedIn, that when you apply for the program, you immediately reach out to the person who is running the program. That's what I did. I reached out to Prasad saying that, hey, thank you very much for organizing the program. I applied for the program. I'm looking forward to be selected, right? He replied saying that, like, good luck. And back in that time, there was like a limit of number of people who can join. So I didn't get selected. I was a little bit of upset that I won't have a chance to learn within the group, network with like-minded people. But I didn't stop there. I thought it is a good opportunity for me to kind of to think differently and maybe in a different approach. So I started to add more people on LinkedIn and trying to understand what they are doing, what they are looking for. So one of my LinkedIn connections, when I applied as a connection request, he was and still is in SA manager in the UK. So he saw my LinkedIn profile. He said, your LinkedIn profile and your background seems interesting. I'd like to connect just to see what are you doing, what is your career aspiration. You can imagine, like, I couldn't sleep at that night that, oh my God, someone at AWS, he's a manager, SA manager, noticed me, noticed my background, and he thinks that I might be fit for this role. I might work on something. I didn't know exactly where I need to work, what I need to do, but at least I had some lead. So we connected. So he called me and we brainstormed some ideas where I am currently. I was saying that I'm taking courses from a cloud guru. I'm learning, I'm doing this and that. And then he gave me some ideas to work on. He said, hey, you can start building a simple website, share on LinkedIn, etc., etc. So I followed his advice, and he was saying that if you have any questions, feel free to message me. Well, that was probably his biggest regret, because I didn't stop messaging him by asking questions, especially around networking and all these like deeply technical questions, where he was very kind enough to reply with resources and just support me whenever I needed. So he became my mentor. So he probably didn't want to, but well, it was his bad agreeing to mentor me, and he's still my mentor, even in AWS. During the interview process, I was messaging him saying that, hey, I'm in the interview process, etc., etc. And then when I joined, we still keep in touch, of course, and we still work in projects together. And this is the also important part, to keep your network close to yourself. Be with people who believed in you when you were at some point where you didn't think you will be in another point. So this network, friends and people, they're really important. So if not him, if not my mentor at that time, I would probably still work on it, but still it would be probably vague for me where I'm going. I have questions, what I need to do. So then, of course, I connected with Prasad. I said, hey, Prasad, do you remember me? I'm that girl over LinkedIn who wanted to join your program, etc., etc. And then Prasad got inspired with my background and saying that, hey, we need to run actually again this sort of program. And I said, let's not limit number of people, right? Because I was one of those people who didn't get this program. Again, it didn't stop me. I'm still here, and Prasad was and still is helping me in AWS as well with all sorts of questions, so not only technical but non-technical as well. So so this idea came up to team up with people in AWS, with passionate people who are happy to mentor other people without putting some limits on number of people who can join the stream and who can learn. So my key takeaway is that ask questions from yourself. What are your skills currently? Look at the job description. What is the job description says, like key requirements, and even in some job descriptions you will see nice to have, like preferred qualifications, right? I was trying to fit even those preferred qualifications as well. For example, it was saying some of the programming languages like C++, Python or Java, etc., etc. So I was trying to understand that, okay, I know how to program in Python. I can read some other programming languages, but what if I add to my tech stack some other programming languages? So I was doing some research, I was watching videos on YouTube, and I was trying to find a project where I can build something and use all these technical tools. And then during the interview process, when you are asked a question, you can say that, yes, there was a project, I built it, I used this and that, there was a gap, I couldn't solve it. I leverage this and that. So it's a good use case for you to understand and see where you're heading, where is your gap. I'm conscious about the time. We've got 1 minute, but this was, in a nutshell, my experience. And if you want to learn more or know more, feel free to please connect with me on LinkedIn.
Jamila, don't stop for 1 minute. We are all here to hear from you. So feel free to go on. If you want to share something, feel free.
Thank you, Ashish. Yeah, I'm just conscious about people's times as well. So yeah, feel free to read Prasad's post. And if you have any questions, feel free to ask in our LinkedIn group. I know I'm getting lots of LinkedIn connections. I'm not able to accept or connect with every one of you because LinkedIn keeps blocking me. And also in the messages, I will try to get back as many of you as I can. Yeah, well, again, if you have any questions, feel free to post in our channel and I will be happy to follow up.
Yeah. Thanks, Jamila, for sharing that story. It's so inspiring. Every time I hear, I get inspired, very frankly. And, like, I can't stop, I can't have enough of that story, very frankly. But yeah, as she said, like, it's important to, like, be resilient in your journey. Right, there might be scenarios when I'm working with one of my mentee right now, and she's trying to search her job, and she's like, I have applied to 100 jobs and no one is responding. I'm like, that is fine. You need to keep, like, be resilient in your journey. Even in terms of finding a mentor, I can give you a few tips, in terms of finding the right mentor for you. Obviously, people might not be having a lot of time for everyone to make, but a few things like, AWS Heroes. If you go to AWS Heroes page or AWS Community Builders, right, you can always be in touch with them, keep interacting with them. And, if your request directly goes into, hey, can you be my mentor? Probably thousands of other people would have messaged them. it might be difficult. So, it's always, like showcase what exactly you want to do. As Jamila mentioned, that, have that end goal with you and start working towards that goal by, keep sharing on LinkedIn and make that connection with the potential mentors that you have. That's what I say, even in the job, like searching, if you go through that 10-step process, there's in one step is that I always say that, while you're studying and while you're sharing your learning on LinkedIn, always create a, like top 30 or 50 list of companies that you would like to apply for and start connecting with those people. Ensure that, the people who are in those companies are in your network, so that when you share something, they keep seeing it. So subconsciously, they'll be like, okay, I know this person somehow. And when you apply, and then you never know who the hiring manager would be. When they will see your CV in front of them, they'll be like, I've seen this person on LinkedIn, let me quickly check. And they'll check your LinkedIn profile. And that makes the process really easy, believe me. Obviously, knowledge is important, but the initial hurdle of, like getting your CV in front of the hiring manager and hiring manager saying yes to your CV, that becomes easy if you activate your network. And I think we are over time for today. We can continue the discussion if you have any questions on this. As I said, I also try and reply to the messages as much as I can when you DM me. But in case if I'm not able to respond, I'm really sorry. Feel free to message it on the LinkedIn group that we have, BeSA program. It's a safe group. It's a private group. We deliberately kept it private so that if anyone would like to ask any questions, no question is a silly question. So feel free to ask questions there. That's the scaling mechanism that we are using. And one of us would be responding to that for sure. Thank you.
Nice. Thank you. Thanks, Prasad. Thanks, Jamila. Thanks, Chris. Thanks, Alex, for answering the question. So it's an interesting group. And as you can see a trend, like people who want to attend, they are attending at 3 a.m. right? So obviously I appreciate that you're taking time, and hopefully we are able to give you the value you are looking for the 2 hours. But if you have any suggestions, anything else we can do differently, let us know. We are all open to suggestions, and we would try our best to help you out as much as we can. So let us know how you liked it. If you like something in this session, share it on LinkedIn. Let other people also get inspired, or let other people also know the details of it, so that everyone gets benefit. We don't want to limit in terms of numbers, but obviously we have some practical limitation with the time and resources. We'll try to help as much as we can, and please spread out the word so that most people get benefited. We will post this recording on YouTube channel so you can watch it later. Share screenshots if you like something, share a quote from this training you have attended, and hope to see you next week. Keep in touch. Let us know how we can improve and how we can help you in getting the best out of this program. Thank you, everyone. Have a good weekend. Talk to you next week. Thanks a lot.
Thank you, everyone. Bye.
Thank you all.
Bye.